go on to the next one. It's called as the mean value theorem. Simply abbreviated as MVP, mean value theorem. All right. So what is this theorem? So let me write down the statement of the theorem first, and then we'll go about understanding what the theorem is all about. Okay. So the theorem says that if I have an equation f of x with me, be any equation, and if this equation is given within a certain interval, okay, this equation is given to us in an interval a comma b. That means this equation does not go from infinity to infinity. It is controlled within a certain range. That means it starts in somewhere, and we only have to worry about the domains from a to b. We don't have to go beyond it. I'll show you what graphically also this means. Let me write down the statement first, and then I'll explain what the theorem itself means. So if I were to have an equation with me, f of x in the intervals a comma b, and if this equation is continuous in the closed intervals of a and b, that means in the closed intervals would mean including a and including b and all the elements between them. If this equation is continuous, and the next condition is if this equation is also differentiable in the open intervals of a and b, right? If this equation is differentiable in the open intervals of a and b, and if f of a is not equal to f of b, then a unique value called C shall exist which is between a and b, such that the first order derivative of this equation at C is nothing but f dash of b minus f dash of a divided by b minus a, and to remember, the value for C is between a and b. This is called as a mean value theorem. Alright, this is your mean value theorem. We're going to spend the next couple of minutes with this. So let's understand what this equation means. So to understand this equation graphically, I'm going to draw a random distorted ugly graph, which really does not matter. Okay, draw Naresh, I have nothing to repeat. Naresh, I didn't explain anything. I simply wrote it down, that's all. I'm going to start my explanation now. Okay, so to explain what I've written on the theorem itself, let's take the x-axis to be x, and I'm going to take the y-axis as the range axis f of x. So these are our data given to us. Okay, also in this range, let me show you where a is. A happens to be here, x is equal to a is here, and x is equal to b is there. Okay, right? I'll just remodify the graph a little bit to make it a bit fancy, right? So this is the graph I have, right? So x is equal to a is there, x is equal to b is here. That means the equation that I have, some equation that I would have, I don't know what the equation is, Doesn't matter what the equation is. Remember, every equation is a graph. Every graph is an equation. So I've already have a random equation with me here. Now this graph when plotted, when the equation when plotted would look something like this shape figure. Now this equation is only between A and B. What happens before A and what happens after B, we really don't care. So let's not worry about this part of the graph. Let's not worry about this part of the graph. We just have to focus on the portion of the graph between A and B, including A and B. That's it. So if I have an equation with me like this is what the first part of the statement says. That is, if I have an f of x equation between A and B, done. Okay, and if this equation is continuous within the closed intervals of A and B, this equation is required to be continuous within the closed intervals of A and B. I hope you guys know what it means. When I say continuous within the closed interval, that means my left hand limit must be equal to my right hand limit. There is no points of discontinuity between this region, and you know very well what I'm speaking because you've done the first exercise pretty well, right? So you should know what this statement means. This equation is continuous between A and B. That means there is no points of discontinuity. That means my left hand limit at A and left hand limit at B and every point between them will be equal. Left hand limit and my right hand limit, I meant. They will be equal. Are we clear with this up to here? So what I've explained now is this statement and this statement. This is the only two things I've explained. Did anyone not understand this? All right, fair enough. Next, moving on to the next part. This equation is also differentiable in the open intervals A and B. Differentiable in the open intervals. Differentiable. When I say differentiable, let's just assume that I'm talking about the first order derivative. Now, what is the first order derivative? What does the first order derivative of an equation give you? Somebody answer this question, please. What does the first order derivative of an equation mean? What do we mean by the first order derivative? Yes, Deepak?
So it gives the tangent.
It gives you the tangent. What are the tangent?
So since the graph is curved,
Yeah.
if we take 2 points, it just comes closer and closer, and it's 1 point that it gives. I'm
Yes.
not able to explain it
That's
properly.
all right. I'll accept that answer to some extent. Yes, that's the right almost, Deepak. So it will give me this tangent and it'll give me the slope of the tangent. So that means I will be able to draw a tangent everywhere here. I'm not going to make the diagram clumsy. I'm just going to draw it now and I'm going to erase it also. Okay, please look into the screen. That means from every element for x is greater than a and less than b, I will be able to draw a tangent. All these purple lines will exist. I will delete these purple lines shortly. These purple lines are all valid lines. They will exist. There will exist a unique tangent at these points. There will exist a tangent, not a unique tangent. There will exist a tangent at these points. That's the meaning of it. So that's the meaning of the second statement, that this equation is differentiable in a comma b, open intervals. Alright, next. We are also asked to find out what is f of a and f of b. Let's find out what is f of a and f of b. So f of a would be there and f of b would be here. There, done. So I have my f of a here and I have my f of b there. Alright, I hope you guys can observe that your f of a and f of b are clearly not equal, because they're not the same point, right? They're clearly not equal. For them to be equal, they must be at the same value, but they're not. They're two different values up and down. So f of b happens to be greater than f of a. So clearly we know that all these three conditions are now satisfied. So we understood what the question means, the graph. We understood what the meaning of continuity is. We all know what the meaning of differentiability is. F of A is equal to F of B fails. That means it's correct for us, it's good for us. F of B and F of A are not the same. Then the theorem says that a unique value C will exist whose value is between A and B. That means there's a number here between A and B somewhere, C, such that f dash of C is equal to f of B minus f of A by B minus A. Now I need somebody to tell me what does this f of B minus f of A by B minus A mean? What is this f of B minus f of A? F dash of B. Oh, sorry, I wrote it as f dash, isn't it? That's not f dash, guys, it's f, just f. F of B minus f of A by B minus A. Yes, Deepak.
So it's nothing but y2 minus y1 divided by x2 minus x1.
Correct. y2 minus y1 by x2 minus x1. So what does y2 minus y1 by x2 minus x1 give you?
The slope of
Correct.
this.
So let's say this point is P for now, and this point is Q. Then the slope of PQ can be found out by the change in y coordinates by change in x coordinates, right? The coordinates of P, please observe, are nothing but a comma f of A, and the coordinates of Q are b comma f of B, x coordinate comma y coordinate, right? Then the slope of PQ is nothing but f of B minus f of A divided by B minus A. So can I say this PQ is a chord to the curve? A chord is a line that touches a curve at 2 points, at least 2 points. Okay, so I can probably call this as a chord as well. All right, I'm going to go ahead and call this as a chord for now. So I have a slope of PQ. So slope of PQ is nothing but f of B minus f of A. Then f dash of C, there is a unique point somewhere here. Let me consider this point to be somewhere here. All right, so let me call this point, this unique point here. There is a point x is equal to C such that if I were to draw a tangent at that point, that tangent will be parallel to the chord, because if two lines are parallel, their slopes will be equal. So you see f dash of C is nothing but the slope of the tangent, and this is nothing but the slope of the chord. So your f dash of C is nothing but slope of the tangent at x is equal to C. Therefore, we get the diagram above. So if I were to draw a tangent at that particular point, that tangent will be parallel to the chord at P and Q. This is the meaning of mean value theorem. Anybody did not understand this, please raise your hand. Has any of your schools and colleges done this? Have they started doing this mean value theorem and Rolle's theorem? Vibha, okay. All right. All right. So your job in this such numericals is to find this value for C. Your job is to find the value for C out, okay? That's what these numericals are going to test you for. So you have to remember the theorem, understand what the theorem says, and then use that to find the value for C. Next, we move on to Rolle's theorem. Okay, I'm going to go to Rolle's theorem, and I'm going to write the statement down there. Observe, the statement is almost quite similar. It is, if I were to have an equation f of x in an interval a comma b, and this equation is continuous in the intervals of, it is continuous in the intervals of a comma b, closed intervals of a comma b, and it is differentiable in the open intervals of a comma b, and f of a is equal to f of b. It's only the third condition that is different. Observe this. It's only if they are equal, then a unique value C shall exist such that it is between a and b, and f dash of c will be what? If I put f of b is equal to f of a in this equation, what happens? F of b is equal to f of a means my numerator becomes equal to 0. Then f dash of c would be equal to 0. That's a condition. Finished. That's your Rolle's theorem. Let's draw it graphically and understand what it means. Let's show the y-axis there, x-axis here. Okay. X-axis there. My y-axis is f of x, my range axis, and I have a curve with me. Okay. There, that's my curve. All right. Then I'll take my x is equal to a here, I'll take x is equal to b there. Okay. So take a look at the x is equal to a and x is equal to b. After I find x is equal to a and x is equal to b, I find out what is f of a. F of a will give me this value there. Observe, f of b will also give me the same value. F of a and f of b are the same thing. If f of a and f of b are the same term, then what happens is the equation becomes equal to 0, right? That means what? F dash of c is the slope of the tangent at c, isn't it? F dash of c is the slope of the tangent at c. Then the slope of the tangent at c is equal to 0. Slope of which line is 0? Somebody answer this. Slope of which line is 0? X-axis, correct. Slope of all lines parallel to x-axis or x-axis is 0. So therefore, we have slope of a tangent at x is equal to c is equal to slope of x-axis or tangent parallel to x-axis. This is your Rolle's theorem. That means, where is my tangent? It is a line parallel to x-axis. So I'm going to copy that line. I'm going to copy of that line. I'm going to paste it there, and I'm going to move it till I get that. I'm going to make it red in color. Done. Are we all good with this? Anybody has a doubt in this? Please raise your hand. This is your Rolle's theorem. Quite simple, right? Yes, Deepak, tell me.
So what does
Sorry?
C tell us? C.
C will tell us where will the tangent be drawn.
So can you give it with some examples, like the first graph you don't know the position and time, so something like that.
Uh, an example. Example would be a numerical itself, just doing an equation itself. So what I can tell you is, it's almost like taking a turn. Velocity from here to there is almost velocity at that particular point. Yeah, I have something there, but it's not that good. It's almost like, let's say an object is taking a turn, right? It's taking probably a U-turn. All right,
Okay.
all right, Deepak. The vehicle is taking a U-turn and going back in the same direction. It's like any car taking a U-turn across any junction. All right. So let's say a car is moving in that direction. So when the car was here to when the car was there would have been a velocity it would be traveling with. The velocity is what? Displacement by the time. The time taken to reach from here to there divided by the time taken. That is, now when displacement is considered, it does not take the entire path into consideration, right? It just takes a state function. Where is it to where was it? So it will just draw its curve across that line itself. But the actual car goes across this entire path and then goes there. So let me find the velocity along that part. Then velocity will be this length by the time taken. Right? Next.
Yes, sir.
What I do is when the car reaches this point, now when the car is at this, I'm going to draw some lines here. I'm going to erase it later on. Okay. When the car is at this point, its tangent is going to point in that green direction. Correct? The tangent is going to keep turning. But when the car reaches there, its tangent will be along the a red line. Correct?
Yes, sir.
Then which
So,
tangent, there are so many tangents here drawn, right? Which
hmm,
tangent will give me the overall answer? See, now my overall answer is this data, this velocity. This velocity is my overall answer. Because this is what I otherwise also call as average velocity. Simply
hmm,
displacement over time. Correct? When is
yes,
my
sir.
average value equal to my instantaneous value?
At that position.
Yeah, that average value equal to instantaneous value. That is what Rolle's theorem will give me.
Okay. Yes, sir.
All right. Right. And the answer is x is equal to c. At x is equal to c, my average value and instantaneous value will be equal. Or my
Hmm.
instantaneous value at c will be equal to the average value of the whole process. That's the meaning of Rolle's theorem.
Yes, sir.
Correct?
So what about mean value theorem?
Mean value theorem also is quite similar. I will ask myself, where will an average value be equal to another average value, another instantaneous value at another point? Same thing. Where will an average value be equal to instantaneous value? But the only difference between the two theorems is, in the below theorem, the instantaneous value will be 0. Correct?
Hmm. Yes, sir.
When will my average value
Yeah.
be equal to my instantaneous value be equal to 0? So if my average value is 0, what does it mean? My displacement is 0.
Yeah.
That means I'm
So
not moving at all.
yeah.
I'm moving, but I'm coming back to the same point where I was. Correct?
Displacement. Yes, sir.
Right?
Yeah.
That's what this would mean. Whereas in the other case, my displacement need not be 0. It can be any value. It need not be 0. That means there is a sufficient displacement. There's a sufficient change in position happening. There's a
Hmm.
sufficient change in my range. So I don't have to start from one point and reach at the same point to get an answer. Got it?
Yes, sir.
That's the meaning of it.
Yes, got it.
They all have a story, guys. All these are not simple theorems that you simply learn and then start doing the numericals. I know these numericals are very easy. When we start doing the numericals based on it, you will find them ridiculously easy. You'll start wondering, why am I doing it at that easy level? But what's difficult is to understand them. I only see a very few students this year understanding what Rolle's theorem is, what mean value theorem are. I mean, what are the graphical analysis based on it? Most 99% of the students I've seen, they simply just learn the theorem. When asked, paste it on paper, you'll get full marks. No students usually lose marks on this. But if you don't understand what this is, then I think you've already lost marks, even if you got 100 in math. If you don't know what these theorems mean, it's as good as losing marks. Right? Please understand them, and you will appreciate them when you apply them in certain analysis.